I'd like to take the opportunity to welcome Gaëtan CHARLERY from our gold sponsor Clextral, and he's also joined by his colleague Louison DUCLAUX, who's also in the room. Take the opportunity to accost these guys whenever you can, see if you can get a good deal out of them. That's what they're here for. Okay. They're here to talk to us about shaping the future of snacking and with twin screw extrusion technology. And as you would have gleaned from my brief talk, these guys, or this company, has been involved in the technology for quite a while, so they might have something good to say.
Good morning, everyone. Thank you, Denise, for the opportunity to talk. Thank you, all of you, also for attending today. It's great to see such an attendance, either on site or online. It's a great pleasure to have the opportunity to talk to you about two presentations today. One about snacking and one on alternative protein later today. I would like to take the opportunity also to thank the CSIRO for organizing and hosting this amazing event. Thank you very much. And it has also always been a pleasure to collaborate with you over the years. So a bit about ourselves. My name is Gaëtan CHARLERY. I work for Clextral as Pacific Sales Manager. I've been working for them for the last 3 years now, and I'm very pleased to be joined today by Louison DUCLAUX, our Asia Pacific process expert, process engineer. He's usually based in Singapore, but we have the chance to have him today. So I will talk. If you allow me, I would like to introduce a bit more Clextral. So who are we? What we do? So Clextral, it's a French company. We are headquartered in Firminy. It's a French city not far from Lyon, about 1 hour for those who are familiar with the French geography. This is where we have our headquarters, our pilot plant. Yeah, the color is not very highlighted in. Okay. Perfect. I will go further into details. So the pilot plants, the headquarters, and our factory are in France. So in Firminy, it's one of the spot that you have, the pin that you have in the middle. It's a bit more than 300 employees worldwide. So we have developed and built a network of subsidiaries and offices around the world, business units in the America, business unit in Europe and Africa, and one in Asia Pacific, so where we work with Louison. Our engineering hub in Asia, to get as close as possible to our network here, is in Vietnam. We have automation, project management, electrical expertise over there. And I work in Melbourne with another guy who is in charge of the after-sales maintenance and everything that we can do on site here. So 12 locations, as I mentioned, 2 pilot plants, one in France at our headquarters and one in Tampa in the US. Both are full furnished with all the equipment to make R&D, to develop new products, new recipe, either in-house for our process knowledge, or also to advise, guide, and assist our network and contacts to develop their own product, basically. The process is something that we really focus on. It's a part of our supply. It's a part of our the services that we provide. And talking about the supply, what we do, maybe it's the first thing I should have talked about. We design, manufacture, and supply twin screw processing lines, processing solutions for food and feed and other applications, but today's topic is food and feed. Those lines integrate twin screw extruders, dryers, and other ancillaries that are required to operate the line. And we also, as I mentioned, provide services such as after sales, wear part supply, and also process assistance on-site or remotely. In terms of turnover, last year we made 85 million euros, which is about 150 million of Australian dollars at the moment with the exchange rate, with 80% of it made abroad. So we are very proud of it. So through the network, subsidiary and offices network I mentioned earlier. Well, there is no map and okay. So in terms of application, as I mentioned, we are in the human food. So basically food applications such as plant-based protein, snacks, cereals, breakfast, ingredients, and so on. We also provide equipment for the animal feed section. So cat feed, pet food, cat, dog, fish, shrimps, anything which is related to feeding. In terms of application, we also provide equipment for the biomass. So it is a booming application today, which is not related with food at all. So in that we have biomass treatment into valuable products, treatment of wood chip, for instance, for hortifiber, treatment of cotton for security paper, such as banknotes, not here in Australia because it's plastic, but other part of the world it's made with us. Also for passport, it's also an application we do. And other industries such as the cosmetic, defense, plastic and recycling, chemistry, which is specific project that we are always happy to discuss about. So what is a twin screw extruder? Denise gave you a very deep preliminary explication, but for us, an extruder, it looks like that. So it is basically a frame with the power unit on the right, which is composed of the motor with one shaft, power shaft at the end. It is after coupled with the gearbox, which transformed the one shaft power into two shaft power, which made us the twin screw active part on the left hand side. So yeah, your left hand side. So it's basically two shafts with a screw profile mounted on it, enclosed within a barrel assembly. So as you can see, we have a few details here, and the feeding section on the top, to infeed the barrel assembly and the screw elements. It is also included with a water pump, so we inject water for the process into the barrel assembly directly. So it is a continuous process, meaning that everything that you infeed, it goes out at the end. The active parts, as I mentioned, it's composed of the barrel modules. So it is a complete set to make the barrel assembly. And also the screw elements, which are mounted on the two shafts. So it is co-rotating shaft, intermeshing screws. It has the benefit of being self-cleaning and positive displacement pumps. So it means that everything that you infeed will be conveying within the barrel assembly with different characteristics being conveyed, being mixed, being shared throughout the process. It has a precise control of the energy input with mechanical energy. So through the sharing which is provided by the screw profile, it increases the energy, so it makes the raw materials heated. And the thermal energy through the heat transfer with barrel. I will explain a bit more that on one of the next slides. To focus on the active parts, the screw elements, so it looks like that. As you can see, we have a splint shaft here with a mounted screw on it. So depending of what you require for your process, we have different kind of screw elements. So for conveying, sharing, mixing, and much more. So it is modular and continuous, meaning that we definitely can change the screw profile when it is relevant to enhance the process, to change recipes or whatever reason. So it is not fixed, you can always change it. We have a wide range of screw profiles designed for different kind of application on the raw materials and the melt. Some are more for thermochemical reason, some are more for shearing reason, conveying reason, depending of what you require. So great mixing and shearing, which is this time depends of the geometry, the flight, the flap of the screws, and the various metallurgies. So this time it's depending of the process and the raw material you use to limit the wear, to limit all kind of wear. It's very useful to have sometime more hard screw profile. So the barrel temperature, our barrels are thermoregulated, meaning that we keep it cool or we can also heat them. So for keeping them cool, we have a cooling circuit, as it is representing on the left-hand side. So with high flow of cold water coming from -5 degrees with antifreeze, so it is the minimum that we accept. The pressure bar, 5 to 6 bar, and it is automatically controlled by solenoid valves. On the other side, when it comes to heating, we also have technology with resistance heaters. It looks like what you have on the right-hand side. It is a continuous temperature between 300 degrees to 500 degrees. Protection degrees IP55, so no leaks. Easy to install, as you can see. It's very easy to install and designed suitable for all type of barrels, so it's like a clamp. We provide drying technologies, so two kinds. The Evolum, which is our value options. It is dedicated for uncoated product because we cannot clean it with water. And we have the Evolum Plus, which is our latest technology. It is this time dedicated. It is extended to coating with sugar because it's cleaning with water. In terms of capacity, for this one we are about around 300 to nearly 4 tons per hour. It is modular design, meaning that we have modules, drying modules that we can add and remove to increase the length of the equipment. Coating unit, so it's one part of the ancillaries that we have. It is for coat the product with sugar or salty coating if you want cereals or snacks. This is a production line of snacking, so it looks like that, basically from 200 to a bit more than 1 ton 5 kg. High flexibility to run different kind of snacking, capable of producing different shapes and formats, adjustable processing to achieve diverse texture. So this is my colleague here who is in charge of developing new texture and new shapes. Easily customizable and suitable for both standard and innovation formulation. And if we focus on the market for snacking, this is what we research. So for the Australian market, we are in 2025 at the moment, and we expect it to increase by 1.4% until 230. Coming up to nearly 4 billion for snack, global snack by 234. And for aesthetic snack, we expect in 2024, we expect, as I mentioned, 1.4% of augmentation until 230. I will leave the floor to my colleague to speak about process now and more about snacking. Thank you very much.
Good morning. I try to make it quick. Gaëtan likes to talk. So yeah, I'm Louison. I'm based in Singapore usually. So I'm the Clextral APAC process engineer. So I will focus on the product here. So I will talk about the direct expanded snack. So as Dennis mentioned, those snacks are made directly at the end of the extruder. So we have the direct expansion. So just to focus, so here you can see the standard, like the regular shape. I don't want to spoil, but that's 80% of the machine we sell are made for those ones. So we try to innovate all the time. I will talk about that. but people really like those shapes because that's the standard that we see on our supermarkets. So if we have a look at those shapes, we have the balls, the curves, and the rings. That's the basics one. And if we have a look at the recipe, so most of the time we use the corn grits because we know that the corn grits is having really great expansion. And then we'll add some ingredients. So here you can see salt, fibers, and calcium carbonate. The aim of those ingredients is to limitate this expansion, to reduce the size of the bubbles inside our product, and also to bring a good color, good taste, which is also really important for our customers. Okay, so here you can see also many shapes that we can make. So our catalog is really big, but as I said, I would say 80% is made of curves, rings, and balls, like the regular one. But it's also important to innovate and to show our customers that we can do new stuff, and also industrial, I don't know, for Halloween, for example, they make pumpkin face or stuff like that. So it's also important to match what the customer is expecting. So here is a small overview. So you can see the grids, the chipstick, the smiley, the fans. We also produce some co-extruded products. Our catalog is really big. So I will focus on the trends, because when we want to innovate, it's good to innovate, but we have to be aware about what is my customer expecting from me. I don't want to innovate just to innovate. So it's really important to match, of course, if we want to sell our product, to be sure what the customer is expecting. So if we have a look at the trends, so those ones are made for Australia, but in the developed countries, they are almost the same everywhere. So the first one would be the health conscious preferences, meaning people want to eat more healthy. Premiumization, meaning good packaging, premium packaging, luxury packaging, black with gold and so on. Convenient formats, formats to be able to share, and also the individual, we reduced in the past, in France, we reduced people were buying less and less individual formats because of the sustainability, and now it's becoming more trendy again. So the format is also really important. The sustainability, trying to buy new packaging made from new raw materials, recyclable also packaging is really important. Digital channel, it can be Deliveroo, Uber Eats and so on, is becoming also really trendy. The click and collect also, for example. And also we focus on the taste all the time to make sure the people will enjoy the snack we will provide them. So if we have a look at the healthy snack, so the extrusion is allowing us to use many different kind of raw materials to make healthy snack. So if you remember the slide, the previous slide, is the number one trend, the healthy food. So that's why we try to innovate in this way. So if we focus on the healthy snack, the aim is to provide good nutrition value inside the snack, protein, fibers, and so on. We can also create new shape, we give natural color, and also we can also work on the texture to try to have something more different. So if we have a look at the recipe here, so to make healthy snack, we usually use the legumes. It can be grits, it can be proteins, it can be flours, and usually we mix that with another kind of starch. It can be, usually it's rice, but it can also be corn, that we know that it's having a great expansion, and then the legume will reduce a little bit this expansion. So we tried, over the past years, we tried to make some new kind of recipe. So we tried, as you can see on the screen, we tried the pea flours, the lentil flours, the blue corn, the sorghum. So we get really different results, and then we have also to change the parameters on the extrusion, meaning changing the screw profile to get the right texture, changing the water flow also, changing the temperature and so on to get the right texture and to get the what the customer is expecting, something crunchy, something melting in mouth. So that's also really really important. And not all the starch or the raw materials are behaving the same on the extruder. So that's also really important. You cannot just put something in the extruder and say, okay, I will get something really nice. It's a long work to find the good parameters. So this is an example of what we can do matching the shape and the recipe for healthy snack. So this one is really trendy. We sell a lot of this one. So that's the pea pods. So the pea pods is made with green pea flour and rice flour, and then we gave this special shape that makes really appealing on the market. And usually it's also coated later on. We also have the multigrain wavy chips, which is also really trendy because it's high in fibers. I will not talk too much about this one, but it's really, really interesting as well. It's a product that we saw on the market for ages, and it's working really well again. Baby snacks also is really like becoming really trendy. We have more and more people asking us about this. So the aim is to have something really melting in mouth for the babies. And then it's also coated. It can be oil-based coating or sweet coating. So this is also a trend that we see those days. And sorry, I'm trying to make it fast to finish on time. So also, what is really important with the extrusion and the great advantages of using this technology is that we can improve our recipe. This is a great example. It was exactly the same in France. So now you have the L-star rating on the packaging, meaning that the industrial must put this label on the packaging to make people know like the impact of this product on the health. Meaning that for good nutritional value, for example, fibers, your product will win points. And for bad nutritional stuff, it will lose points. For example, if you have high fibers in your product, you will have a great rate. If you have a lot of sugar, you will decrease the rates. And then here we have what we call the Choco Cups. So the version 1, it was the one on the market for ages. And then the health rating star was only 3 stars. And the industrial came to us to improve this. And thanks to extrusion, we were able to increase the fiber, decrease the sugar a little bit, like divide by 2 actually, decrease also the salt to try to win some stars on this L-star rating system, which make also a really big importance on the marketing side. So by changing the parameters, we changed the recipe, and by changing the parameters, we reached the same final product. And this is the last slide. So this one is the crisp. So this one is also becoming really, really trendy because with the extrusion, we can make those crisps, which are made usually with 80% of concentrate. So it can be soy, it can be pea. And then we mix it with starch to have a great expansion. And there's those small extruded snacks are used in other applications. So this one is like cereal balls, but it can be also included in muesli, ready-to-eat muesli, for example. And this is also becoming more and more trendy, and industrial come to us to perform some trials like more often than in the past. So just to conclude on this, on the process side, we can see that extrusion allows us to work, like thanks to be able to move, to change all the parameters, we're able to work on many different recipes, many different shapes, that makes us the possibility to improve our recipe and to develop also new innovation, to be able to match what the customer is expecting in terms of trends. So here it was more focused on the health side. Okay, so I'm done. Thanks a lot for your attention. And if you have any question, I will be happy to answer it.
Osvaldo.
Yeah, hello. Yeah,
Good morning, how
good
are you?
presentation. I have a question because you know when you do the graph showing how it's going to be the market, why in 2028 you are seeing a reduction in the snacks?
I give the mic to Gaëtan for this one.
I mean, who got that information? Because it's linking with Dennis was saying, you know, sometimes it's going down, but I would like to know who is predicting that.
Yes, so it's predicting by your marketing department. It's about cycling market. So maybe crises, maybe regulations also that could arrive in Australia. So it's just an expectation, a theory. Nothing is really set up at the moment. It just to expect everything. So
what we can do ourselves to, I mean, go against that decrease, you know, because we are trying to make better product, you know, you mentioned it.
Yeah, I totally understand. What we can do, I don't have the answer on my own, to be honest. So it will be, yeah, market evolutions, avoid transport, any transport issues, for instance, keep importations, things like that. We don't really have the answer.
Thank you.
Thank you.
Are there any other questions in the room? Yep, one more.
Good morning, everyone. My question is with regards to the co-rotating screw. Why do Clextral offer that, and what are the advantages, if there are any, with the counter rotating screw?
So yeah, for the co-rotating screws, what we know, so we have many different applications, and we know that having the screw going in the same way allows us to have like a great shearing. Also like we have an application which is really relevant for this one, is like the flavor encapsulation, meaning that you will, if you open a tea bag, you will find some small sugar matrix that is encapsulating the flavor. So this process is also made on our machine, meaning that you put a sugar and then you will create an emulsion with like a all-base flavor. And the aim is to be able to have the same amount of flavor in each small bubbles of sugar. And then with the, like having the screw going in the same way, we have like a great shearing, but also a great mixing. So we know that we have a really great dispersion inside the extruder, meaning that also, so for flavor encapsulation, it's really important, but also for snacks, it means that you will have the same, I would say, through your process, you will have exactly the same texture all along, and then you will create like a really great, like in the intermeshing zone, the mechanical energy bring into the machine will be different if you have like a co-rotating or contra-rotating screw. And we know that with the co-rotating screw for all of our application, it's the best. I mean, it's the best way to produce this one. Yeah. Maybe Dennis, you know more than me on this one.
So, the co-rotating twin is the common machine used in food processing, no doubt. As far as emulsification of oils and fats into melts, my experience is that the counter-rotating twin, if it's configured correctly, can do a better job, but it doesn't do as good a job at melting. So it's a case of understanding what is the product you're trying to make. So every different screw geometry, every different screw extruder option has positives and negatives, as I highlighted briefly in my slide. There's no such thing as a perfect extruder. Don't worry about the salesman. There is an extruder, and it can be, if it's configured appropriately, it can do a good job. Doesn't mean it's the perfect job. It will do an acceptable job. And we're here to feed people. We're not here to make perfection. All right, it's delivering products in good functional products in a acceptable format. That's our job. Doesn't mean perfection. Yeah, but they do build some decent machines. I'll give you that. I think there was one question from overseas. I believe Keith wants to ask a question again. This is your last one, Keith. You already had your share.
I do apologise. Thanks,
So
Dennis.
should.
Thanks for that. Yeah, Louison and Gaëtan, thank you very much for a great presentation. Gaëtan, I didn't recognise you with your new beard, so very, very fetching, very nice. My question is visiting clients' sites this year, troubleshooting on some of the problems. The majority of the issues have been around preconditioning. And I have to say, probably one of the best preconditioners was actually a Clextral, which is a twin shaft top loaded, which allows you to do dead stops. I'm hoping everybody in the audience do dead stops when they're testing. My question is, I enjoyed your presentation, but there are many snacks which are 3G snacks, and I wanted to ask you, how important is preconditioning for both either 2G snacks or 3G snacks in your experience?
So usually at Clextral we do only direct expanded snack. So we don't use the preconditioning for snacks. The only thing that we use, the only application I would say that we use the preconditioner for is the flakes. So we have like also flakes, so it's a long machine, and you need to pre-cook your starch in the preconditioner to make sure you will not expand also at the end of the machine. So you need to cook your starch without expanding at the end, because you will, like the aim of flakes is not to expand like a snack. So that's why we use the preconditioner. But mainly we use the preconditioning for fish feed and pet food to make sure like we will increase as much as possible the digestibility of the proteins and the starch for like the fish and also the pets. But yeah, for snacks, we don't use that much, only for flakes.
Okay, thank you. That's great. Thanks, Dennis.
You're welcome, Keith. Thank you for the question. On that note, I'll say thank you.
Thank you very much,
both of you.
Now go to the session 4. That's the innovation in extrusion equipment technology. And the first presenter speaker is from Clextral, Louison. He's the Asian Pacific process engineer. His topic is breakthrough in plant-based protein extrusion.
Hi again. I hope you still have a little bit of energy for this one. So we were talking about snacks earlier. I will focus on the proteins now, and I will show you what are the latest innovation that we develop at Clextral to be able to produce like to match what our customers are expecting. So, we can see the map this time. So I don't know, I will not go through this, but so yeah, maybe I will just go back on our location if you're interested in. So our headquarters is in France. I don't know, for those of you who have already been to France, so it's really nearby Lyon. And so that's our headquarters. We also have like a subsidiary in the US, in Florida, in Tampa. So that's our main location. In France and in Tampa, we have R&D center, so our own pilot scale extruders. So feel free to contact us if you want to perform some trial. We have many different extruders you can try there. EV32 for R&D, we can also scale up. So, if we focus on Asia Pacific, so we have people. We are actually a small Clextral here. So our main office is in Ho Chi Minh in Vietnam. I'm based in Singapore. We have Gaëtan and Eric here in Melbourne. We also have a guy in India. So yeah, we are almost everywhere. So if you need to contact someone from Clextral, feel free. I will go really quickly on the market and application. So now I will focus again on the human food, and we'll focus on the first one, the plant-based protein. So I will go quickly on this one. This one is interesting as well. We try to give the opportunities to everyone to try our machine. That's why we are expanding our R&D network, meaning that with our partners, you can also try our machine. So I will just focus on the Asia Pacific one, maybe in Australia. So we are working with University of Queensland. So they are there, the FABA team. We also work, of course, for ages with the CSIRO. So the aim is really for us to give the opportunity to people to see our technology. I can also come on site to support if you want to develop new recipes, just to see the machine running and so on. So we also have like I would say our main platform in the region is in Singapore. So with Nurasa, maybe you heard about them already. So there is an EV32. You can try like the proteins, it can be HME, TVP, snacks, and many different applications. Okay, so if we focus on the protein, so we have two ways of producing the protein through extrusion. So I'm sure you all know about that, but for some people who are maybe only on snack, I will just go quickly on this one. So we have the dry process and the wet process. So in the first step, I will focus on the dry one. So here you can see a layout of. So here you can see the extruder. Here. So it's really adhered. It's the really important part of the processing line. Then you have the dryer here. So here it's an EV dryer. So Gaëtan showed you this morning our two main dryers, the EV and the EV Plus. So on this one is the EV one. Usually, so it's kind of a large range, but we can go from the small machines. So EV32, for example, we can go to 100 kg per hour. And for industrial line, we sold some line, for 3 tons per hour. Okay, so it depends again on the type of raw material that you are using and what you are looking for as a final product. So if we focus on the raw materials, mainly I would say the TVP are made from soy. Usually it's a deflated soy flour. It can also be soy concentrate, but for like, of course, the price, the cost of the raw materials, usually industrial use the deflated soy flour. And it's working well. So we heard a lot already about the proteins, what makes a good protein. So also for us, that's what we use when we try new raw materials. That's really important. So extrusion is not, okay, we can say it's a black box, but you cannot put whatever inside and then you will have like a wonderful product at the end. It's not working like that. That's why I'm here. I have my job. So we need to find the good parameters to match the raw materials you are using, the good thermical energy, the good mechanical energy to achieve what you want to achieve. More and more, we try to, like, people are less and less interested in soy, I would say. So pea is also a really good source of protein. It's working well for TVP. And we have wheat as well. And we have like new kind of proteins like emerging, and it's working for all over the world. Even in the US, we're working with those kind of proteins that we call the pulse proteins. So in this category, you can find the mung bean, the chickpea, the lentil, the fava bean, the lupin. So we have many different things, and also ingredients, so starch, flours. The aim is also to be able to match the target. Maybe sometimes you cannot, depending on the functionality of your proteins, you cannot use 100% of those proteins. That's why you need to add sometimes other kind of proteins to add starch. So it really depends on what you want to achieve. So this is an example of what we tried at Clextral. So for the shapes, like you can do many different things, but you always have to think about what will be my final product, meaning what will be my post-processing, what do I want to do with my TVP. If I want to grind my TVP after extrusion, there is no meaning of making a really big TVP, which might be more complicated to produce. So you always have, if you want to make like a chicken patty, or if you want to make like chicken chunks or something like that, you have to think about what will be my next step, and not like focusing only on the extrusion. So if we go back to this slide, so we tried many things. So the regular one would be with the soy concentrates. So this one, the wheat gluten also is something that we know it works well. So it has been there for ages. But the new ones would be like for example, the sunflower concentrate, the lentil concentrate, the fava bean as well. So we can do many things, but sometimes we have to mix. For example, some proteins are not that functional, so we need to mix them with pea or with soy, because we know that pea and soy are really like working well through extrusion. And also, so that's the small things that I'm adding here. For TVP or for HME, if you use a soy concentrate, for example, from a supplier A and a soy concentrate for supplier B, both are soy concentrate, but it will not react the same on the extruder. Even for the same supplier, if you change, like you don't understand what's happening, you call them, oh, it's a new batch, we changed the way that we extract the protein. So it's also really important. Even from the same supplier and the same reference, sometimes from one batch to another, you have to adjust your parameter. So this is just example of the post-processing. So with TVP, you can make like tuna tartare, sausages, burgers. You can make many things. You can mix the TVP also for pet food. It can be used to mix with fresh meat. So we can do many things. So that was for the dry process. Now we'll focus on the wet process, and that's where we put a lot of efforts on this one. So I will show you some latest innovation. So just to show you the regular process, so this is the layout. So you can see again, so you have the upstream, meaning like the hopper, the mixer, and so on. Then you have your extruder. You can see that the extruder here is longer than the one for TVP. So we need a longer machine to be able to have like a good mixing, a good shearing inside the extruder. And also you can see here, so that's the specificity of the process, the cooling die, which can be which is thermoregulated. So for this one, it's an industrial one. So you can see we have 5 different zones, meaning that you are able to really control your temperature and what's happening inside your cooling die. That's really important. when we have a look at this one, usually we are like the extruder can swallow the raw materials, but the limiting factor is the cooling die, because the proteins needs time to be able to recreate the bond between each other. So usually your extruder can have a really high throughput, but the die is like the limiting factor of your line. So if we have a look, I will go quickly on this one. So that's with the regular die. So usually we go to 8 millimeters and we work on a thicker product because some of our customers were asking for this to make like wall cut products. So we are now able to go up to 25 millimeter. If we focus on the recipe, so the basic as well are the soy and the pea. And we also try new raw materials. So the same with the pulse, same from TVP. So we tried those ones. And I did a trial a few months ago for a customer in Singapore with insect protein. So the aim was to see what was the maximum rate of insect that we are able to add into the process without like having a lot of disturbance in the process. It was, sorry? We went up to 30%, but like organoleptic, I would say, profile of the product was not that good, but the process was fine. So this is the example of the post-processing, but what I want to focus on is that I told you that the limiting factor was the cooling die. So we developed a new one. So you can see, so I will show you a video. So maybe you know this guy, because he's really famous at the CSIRO. He worked here for ages. He was working on the EPT. Now he's our like protein guru in France. So you can see we have two outlets of the extruder. That means by adding this cooling die after like industrial extruder allows to increase the throughput. So we can go up to a 1.2 ton per hour. So this colleague is going to the gym every day, and you can see that he's struggling to open the stripe. So that means you can have like something really hard. Of course, you can like work with the parameter, add some water, more water inside to get something softer. And to get something softer, we develop something else, another technology, which is to answer like another request from a customer. So the first one was to increase the throughput. This one is to work on the texture. So we developed what we call the Galaxy technology. So this one is, we can call that like a dynamic die, meaning that you have your extruder, then you have like a cylinder, and inside you have an inner cylinder, and then I think I have a video. It will be maybe easier for this one. I will go back after, so I will show you this one first, so you can see how it works. So the aim was to make the proteins rebonding like in another way, like under a dynamic atmosphere. And the result is that we get like a really different texture from what we observe with the static die. We can have something like more soft, like softer. And then also the way you will see when they will open the stripe, I think it's on the video, you can see that the way that the proteins are bonding to each other is different than the static die. So that's also a great opportunity for the industrial actors to be able to propose something new to their customers. So here you can see the machine running. So the outlet quite different, but it's really easy also to use. It's even more easy to use this one than the static one. So you can see here, it's really different. And this colleague is not going to the gym, so you can see it's really like, it's really soft. Okay, so I will go up. Sorry, I'm almost done. So if I go back to this one, so the texture is really unique. So this has been developed with a Swiss university, Sion, right? So we scale up for this one is like a EV53. So this like Galaxy is made for EV53. So dynamic system, you can adjust the rotation, like the rotation speed. And also what's really important is that it's in the same way that the static one, it's thermoregulated. So you can see the thermoregulators here. So you can really like select the zone. And also the inner cylinder is also thermoregulated. So you can really like have a really focused process. About like the throughput, so for this one, it's up to 400 kg per hour for the soil and 300 for the P. P is like, for those who have tried, P is more complicated to like have a good stripe at the end than soy. The product is 10 millimeter thick, and yeah, start up and shut down, like it's way easier than the regular die. So in production mode, you can see the inner cylinder inside the outer cylinder, and then you can, like, you know, Clextral machines are openable to be like fully cleaned. It's the same for the Galaxy. We can open it to clean everywhere, even when you go. So in France, I don't know here, but the soy is like allergic, like materials. So you need to really clean deeply your machine before going to another production, I would say. So that's why this one is really important. So okay for this one. So this is the last slide. I'm almost done. So we cannot tell like one technology is better to another because it's really different, and we cannot like compare them. It's just depending on what we want to achieve, what the industrial want to achieve, we're able to answer their request. Meaning, like if they want to really work on the texture, they should go with the Galaxy, like meaning something softer, even for fish analogs. And also, it depends also, of course, on the raw materials they want to use. So yeah, that's our main innovation. So if you just have to get some takeaway from this presentation, is just like we are trying to innovate for industrial, also at R&D scale. But for this one, is like we try to answer to requests from our customers. The first one was to increase the throughput with the high capacity die with the two outlets, and then also work on the texture, which is the Galaxy technology. Okay, I'm done. Thank you very much for your attention. So if you have any question, I will be happy to answer them. Or we still have a booth at the very end of the room there, so feel free to drop by. Thank you.
Thank you very much. And we have one question online. Jason, you go first.
Thanks, Louison, and yeah, thanks for mentioning UQ. Our series going very well there. But I had a question with your rotating. It's really interesting to see your rotating device. So you're applying a Couette flow to that system, and do you see very different flow? Like the internal structure is very hard to see from here. The internal structural components and what led to different softness. And I'm assuming it's that balance between a Couette flow and a Brazil flow in that die. Is that the major difference in that system, or is there greater things around cooling and stuff that's there that I didn't appreciate?
Okay, so yeah, so I'm not sure I got everything because the Australian accent is a mess for me, but I'll try to answer. Sorry for that. Just let me know if it's not clear. So, oh, sorry. Can you just put the screen again? Thank you very much. I just want to show you this one. So here you can see you can see two pictures on the screen. So on the right hand, you have like the static one. So you can see like the fibers inside the stripe. You can see the way the proteins are bonding inside. And then if you compare to the other one on the left side, like you can see the arrangement of the proteins is quite different because they are not like bonding in the same environment, meaning that under like the dynamic, I would say, movement of the die, you will create like different kind of bonding between the proteins. It's what will give you the like the different texture. And for the water amount, I can tell like the one I showed you on the video, the water amount was quite low because it was really hard. But usually we use almost the same. We just use a little bit more water in the Galaxy one because we need also to be careful with the pressure. So of course the material can handle, like the equipment can handle the pressure, but as it's dynamic, we have to be careful to like manage the pressure in a better way. And also as we are looking for this softer texture, we increase like by 5%, I would say, the moisture content. it also depends, of course, on the type of raw materials that you are using. But for same raw materials, we use like almost 5% more water in the Galaxy die.
Thanks.
Did I answer everything, or?
I'll have to, yeah, I'll have to come back to it. I think it's just thinking about the flow. I was just trying to think about the flow patterns in the cooling die, because your normal dies are Purcell flow, and these dies are Couette flow because you've got a sliding surface.
Okay, thank you,
It's hard to
Jason.
communicate
Anyone?
online.
Yeah, feel free to reach me if you have any question about that. Will be easier, I think. Thank you.
Any questions on the floor?
Thanks for the presentations. Can you actually stop the rotations and make it work as the static one, so you don't have to buy both?
No. No, it meant like you can reduce the rotation. So you can work with a really slow rotation, but the aim is really to have like something, because you can just go with the static one. If you want something not like rotating, you will get like a different one because it's not the same shape. Like you will not get the same texture and so on. But the aim of this one, and also the like, it's important. The rotation is important to make sure like the product will go through also the die. So that's why you can choose the speed, and with the speed you will have like different results. But this one needs to be like the inner cylinder needs to be rotating. Yeah.
Okay, any further questions? If not, let's, there, Carsten.
I'm just curious about the insect trial. Can you tell me a little bit more? Is it all NDA top secret? The insect trial.
Yeah, I can. What do you want to know?
Yes, the percentage, and what was it for, and how did
Okay.
it work through?
Okay, so basically the aim, so the company was extracting oil from the insects, and they were having like byproducts, and it was like high in protein, so they wanted to know how they can use it. So we tried through extrusion. So the aim was more about valorization of the byproduct. The result where you can go up. So again, it's for these raw materials we're using with soy. So if you use like another soy supplier, if you use another insect supplier, it will be completely different. What we observe is that up to 20%, it was like the process was stable. The taste was okay. It was really umami, like the taste of the insects. And then when we tried to go a little bit up, like when you open the stripe, you can see like you see less and less bonding, like less and less fibers, but the texture was more like plastic. Yeah, plastic, and also, if I remember correctly, the pressure dropped a lot when we increased in the extruder. So yeah, I think it's interesting because maybe that's the future of food as well. Like we talk a lot about plant-based, but also insect is an option. So for now, and with these raw materials, for sure we can do like HME with 100% of insect. But maybe one day, we never know, we'll have like the good raw materials made from insect, and we'll be able to create like a 100% insect.
Thank you.
Yeah.
Can I follow up the question? You know, the insect protein that they are using the most is cricket.
Yeah.
But you know, there could be an allergenic problem because you know, and this is the concern that I have with the security. You know, I mean, we are trying to do too, but you know, it's a concern that you know is bothering me a little bit. I would like to listen your comment.
Yeah, about like the stuff that crickets can be allergic materials.
Yeah.
Yeah. So yeah, it's also the case for soy, for example. So that's why you need to first I would say like clean the machine, of course, all the time. Like when you want to go for something else, I'm not really sure where we stand with the like introducing with the FDA and so on. Where we stand with the cricket, if it's like I don't get the English word now, but if it's recognized as like an ingredient that we can use in the industry right now, I think we are on our way to. I don't know if that's the case now. Yeah. Yeah. So that's why we can see that people are asking more and more to perform some trial with this kind of raw materials. But it's the same, like, I mean, maybe crickets like is allergic materials, but I mean, it's the same also for soy, and maybe with other kind of insects. I think some people are working with worms. I've never tried worms. It was also crickets. Maybe it's different. I don't know. I'm not a specialist in this area, but maybe if it's like pea is not allergic and soy is, so maybe it's the same also for insects. So we just need maybe to find the right one. Yeah.
Let's thank Louis
Thank you.
again.
Thank you.
Right.